So let's start talking about my monitoring configuration. I have 3 VMs configured on my Proxmox cluster, each one on a different Proxmox node. As you see here. The monitoring VMs are equipped with time series databases to collect and store performance metrics from all Proxmox cluster nodes and virtual machines. Additionally, they aggregate system journals and var log data to enable centralized logging and streamlined log analysis. All these 3 VMs receive the same monitoring data simultaneously, and they are accessed using haproxy load balancers and keep alive D to handle virtual IP address failover. In this way, all my monitoring data is highly available without me having to configure a database failover solution. As far as the TSDBs are concerned, I'm using InfluxDB, Prometheus to store the VM and Proxmox cluster metrics, and Grafana-Loki to store the VM logs for central log access. All the Proxmox nodes are pushing the metrics to InfluxDB. I have chosen this solution because the InfluxDB adapter comes standard with Proxmox. As I can see here, I created Proxmox and Proxmox backup buckets in my organization for all 3 InfluxDB nodes and created the required API tokens. Here in the Proxmox data center, I created the adapter configurations for the metric servers. So Prometheus is relying on exporters configured for the monitored services, which make the relevant metrics available in an API. Prometheus is connecting to this API and is scraping the metrics periodically. I configured a node exporter, pbs-exporter, Postgres-exporter, and haproxy-exporter in my setup for now. Keep alive D-exporter and DNS-exporter are planned for later implementation. Finally, once I am deploying Apache Kafka and Kubernetes, I will need to configure additional exporters to monitor those components as well. I configured Node Exporter on the VMs in the Proxmox cluster. Node Exporter makes all the VM metrics available in an API. Prometheus is connecting to this API periodically, is scraping the metrics and is storing them in its database for further access. I have pbs-exporter configured on my backup servers. pbs-exporter follows the same principles as Node Exporter and once again provides the backup server metrics to Prometheus via an API. Postgres exporter is installed on all the Postgres nodes and is following the exact same principle. haproxy comes with a standard API already present to expose the metrics to Prometheus, and this API just needs to be activated. Prometheus itself is running as a service on the monitoring nodes. And the service is configured using a config file with sections for different scraping jobs. Next up, I'm using Grafana-Loki for central log access. Here I have Alloy installed and configured on all the VMs. Alloy is pushing the var logs and the journal of the VMs periodically to the Loki database for further access. Grafana is deployed on all monitoring VMs and serves as the front end for accessing metrics and logs. It uses a PostgreSQL cluster as the backend for storing configuration data. The deployment is load balanced via HA proxy with high availability ensured through keep-alive-D, which provides a virtual IP address for failover support. I've already talked about my Postgres cluster configuration earlier. The Postgres cluster is fully configured for HA failover and for Postgres load balancing. I have InfluxDB, Prometheus and Loki configured as data sources for Grafana. This provides Grafana with monitoring metrics, which then can be displayed in specific dashboards. Grafana supports dashboard scripting language for custom visualizations. Additionally, pre-built dashboards shared by the community are available at https://grafana.com/dashboards. Currently, I'm leveraging several third-party dashboards with minor custom modifications to suit our environment. I have one dashboard for monitoring my Proxmox nodes. As you can see here, these are the metrics for all my Proxmox nodes with CPU and memory utilizations, network latency, throughput, storage configuration and utilization, and so on. I'm using one dashboard to monitor the backup server storage availability, together with additional statistics like load averages and CPU utilization. In addition, I'm monitoring my backup service here. It mostly displays my storage utilization and the number of snapshots stored. The Postgres dashboard is displaying database buffer statistics, number of inserts, updates over time, and session statistics next to CPU and memory utilization. The Node Exporter dashboard lets me display all the metrics relevant to a specific VM. Finally, the HA proxy service dashboard displays all the statistics on HA proxies like HTTP response time, failures, downtimes, and so on. There are additional exporters available to install to integrate more metrics with Prometheus. The ones I have planned are exporters for keep-alive-D and for DNS. Now to Grafana-Loki. Loki is displaying the collected var logs and journal logs of the VMs. In section Explore Logs, the Services section is providing information about the collected logs over a given time frame. The Server tab is organizing the logs by VM and lets me drill down into specific logs, as well as providing filters to select specific entries. Grafana provides an Alert Manager component, and there is an Alert Manager for Prometheus as well. Implementing them is still on my list of activities in regard to monitoring. So this is it for a high-level overview of a monitoring configuration. There will be additional videos coming with corresponding GitHub readmes to cover the configuration in detail. If you enjoyed the presentation, found it inspiring, or want to dive deeper into the topic, don't forget to like and subscribe. Know someone who might benefit from this? Feel free to share it with them, and if you think I can help with your project, let's connect. Thanks for watching, see you next time.